Hello everybody, it's Alex here from Art of Smart. Today I'm going to be showing you what we have been working on up at head office. As you can probably see behind me, we have been working on some beautiful lighting panels that are going to go into one of our projects that are up and coming. So these lighting panels are going up into one of our Newcastle projects. We've been doing that with one of the Art of Smart partners. They did an absolutely fantastic job for us up there. We've gone up and given them a hand. You will have probably seen that on the Instagram stories and on YouTube as well. So this particular job is a combination of part new build, part existing property. So we went up and gave the partners a hand. What we had to do was lift a lot of floorboards up, but then on the back of the property, we went out and there were a lot of joists already drilled for us. As I say, the Art of Smart partners did an absolutely fantastic job for us up there. The property itself, as I say, is up in Newcastle. It's right near the beach. It is absolutely stunning, and once it's finished, it's going to be amazing. Now, as you know, Art of Smart, what we like to do is like to do a big pre-wire. So for this project, what you will see in a minute when we talk through the two panels that we've been building is there a lot of space, and that's because a lot of things have been pre-wired in, ready to go, and as and when the client decides they want them, if they want them, it's already there for them basically. They can just fire it in straight away. All we're going to be doing is coming in, adding modules, adding a couple of links in, a little bit of programming. As you will have seen, all of our racks now are built at the Rack Build Lab up at head office where I am now. There's actually a rack being built right next to us off camera. I'm sure we'll get some B-roll of that for you as well. So the whole point of it is that we've got that big pre-wire in place, the cabling infrastructure is already in place, and effectively all we do is we just add onto the end the equipment, program it in, and everything works seamlessly. So now what I'll do is I'll actually stop talking and show you some of the panels that we've been working on. So we'll start off with the little one. As you can see, it's a 5-slot panel. Currently installed, there are 2 8-channel dimmers. Now this is what we do when we're doing the pre-wire, when we're doing the pre-build, sorry, up at head office. So we've got our modules in, we've created our links, all these links are handmade, we've got our DIN rails in, and we do everything that is on this side up here. Basically what we do now is when we turn up at site, all we do is take this off, mount it into situ, drop the load cables into this side of the DIN rail. It's all pre-programmed because we've already got a cable schedule, we've already got a lighting schedule, we've already got a lighting plan. Everything goes into this side, we power it up, and it works. It's as simple as that. So as I was talking about from a pre-wire perspective, this is the space that's left in this panel. We've actually left space for 3 modules. Now that could be relay modules, it could be dimming modules, it could even be RGB, RGBW, DMX modules could go into there as well. But on the plan, we will know exactly what's going in. When we turn up to site, we'll drop the DIN rails in and we'll basically put that side into it. If and when the client decides they want something, all we need to do, as I say, is basically take that with us, just that side. The modules, the links, the DIN rails already in with all of the loads terminated onto that side. So that is the one that is effectively ready for the pre-wire. There are 16 channels, 16 loads still to go into that one, so it's not like it won't be used. And next we'll look at the big one. So this one is the big one. As you can see, this one, same again, is a 5-slot panel. However, this time it is completely been filled. Now in here, what we have is we have 2 more of the dimming modules, there for lighting, and then we have a relay module, because in this property, there are also Control4 blinds going in as well. So as well as these 2 here, what we also have is we also have 2 DMX modules as well. Now what you'll notice is we've got this all on its side, and that's because when it goes to site, this is going to be the first time that we've physically installed one this way mounted. Because of the space, because it's in an apex of a roof space, what we'll do is that one and this one will go in on their side. As you can see, we've installed a containment down the side of it. This one is 75 by 75 galv trunking. We've got a fuse spare. We're gonna have basically a spare slot, which I'll explain that one in a second. Another fuse spare there. They are isolators for the DMX, so that we can isolate these individually and have that additional control. Then next to that, we have another blanking plate. We have a socket, obviously for power. And then on the end over here, this is going to be a data point. Now, what we will need is for the DMX engine will be mounted to the wall there. Our 2 drivers, 1 per DMX, will go onto there because it's RGBW. In this side here, the actual engine itself needs a plug top, so that will go into the socket, and it leaves a spare socket. Very similar to when you're doing an electrical installation, where it's best practice to have a socket just below it, so you've got that access to power if you're ever working on it. We do that, so you'll have a spare socket there. And also from our perspective, a data point is always really handy to have as well. So down here we'll have our data point. From there as well, what we'll also do is continue the data on. So this is basically the low voltage side, and then we will feed our modules using the Cat6 cable that comes into there as well. So because of the draw that the RGBW will actually take from the system, what we need to do is we need to use a driver that's big enough. Now the drivers that we use have 2 outputs on them. What we'll do is we'll take a feed to this side and a feed to that side for each of our DMX modules. So what you'll see down here is our drivers. You'll see one there and one there. You'll have your usual incoming 240. And then from that, what you actually have is you actually have 2 tails coming out for your 24 volt feed. Now, what we'll do is we'll use this point here as where we will join those together to give it that permanent feed. So rather than having it all in the trunk in with Wagos connecting them up to be fed out and split either side onto this through there, what we'll do is we'll do it nice and neat and give it its own dedicated point. As you know, we label everything. So these will be labeled to identify which module it is controlling. And on the front of the blank plate, it will also let you know what's inside. Now you will notice that what we've got in here, we've got the air fly lead. Now that is simply because there is potential everywhere on the entire board. So we put it in there. Even though there's not going to be technically any power cables going into there, we do it as an extra precaution. On a side note, what you may have seen on Instagram or on our YouTube pages is that we have the AOS Training Academy. Now some of the links that we've got on here have actually been recycled and reused from the AOS Training Academy. So these fly leads that would have been used for demonstration purposes or when people were practicing on their panels upstairs, it would normally link from the DIN rail into the module. Some of them are just too short for the way that we dress them in. They still serve the function whilst they're doing the training, but they're too short for the way that we dress them in. We don't waste them, we recycle them, and we'll use them in here where we can. So a lot of people message me saying it's a bit overkill, isn't it, having it sort of ferrule both ends and having it indented. The reason it is identified is because we've recycled and reused them. But again, there's no harm in doing it. Every single one of these is obviously earthed to the faceplate as well, and earths the back of there. All of it is connected through to where our main earth will come on. It's all been bush and lock ringed on, so it's all completely earthed and safe as well. So the whole point in doing this was so that we had the opportunity to see whether it works for us building it off-site. As you know, whenever you go to install a panel or when you go to install a consumer unit or basically any large complicated piece of equipment or system or infrastructure, you always end up in a cupboard on your back for half the day trying to figure out what's going on, and you come out with cramp, cuts, bruises, and it's never ever comfortable. The whole point in this area is so that we can experiment and see what is the best way to do it. Now this time you will have seen from Instagram that we did it actually lay flat, which is very confusing for me who's used to installing things sort of in an upright position, as I'm sure most of you are. But what it did give us the freedom to do is to move it around and to make sure that we were as comfortable as possible. Now, one of the tiny little perks is obviously we had Amazon on in the background. We had Amazon Prime on in the background, we had movies, we had YouTube. It's a very nice environment to do it in. And why not? If you've got it, why not use it? So what we'll be doing now is basically we'll package it up as best we possibly can, give it a lot of protection, give it the wrap that you will have seen the AOS distribution use. It'll be stored on its back. It will then be taken to site. We will take it out and open it up on site. Once we've got it up into that sort of complicated, awkward position where it's going to finally be in, we know it's going to be protected because it's all wrapped up. And then what we'll do is we'll unwrap it, we'll hold it to the wall, and the other lads will fire it in. It's as simple as that. Then from that point on, what you'll see, the only bit that we kind of have to do on site, all the programming is done off site. Ollie and Drew have been working hard on the background of that. The only thing that we need to do on site is take in our outgoing legs, our loads. So all of the loads on site, you will see this when we actually go to install it, it's all coming from up here. So it's going to be in containment, run down, and it'll drop into here. Once it drops into here, one thing you will notice I haven't mentioned so far is we've done it side entry. Now Control4 lighting panels come with the knockouts on the top, and they do come with a couple of knockouts on the side, not really intended for that much lighting. What we do is we have holes sorted out and we've put our lock rings onto the side there, and it gives much better cable entry. We've done one above each of the modules. So as I say, when we turn up to site, we feed it in by module, the longest run up to the top. It comes through here, it's split out, and it goes into the DIN rails. Same for that module, that one, and so on. Then what we'll have is at the bottom here, which you might not be able to see, we've just got a smaller one that we've taken out, and that takes it up, and that gives you your low voltage size and your data to connect it obviously to the rack. So that's everything I wanted to talk about today. Thanks very much for watching. These are going to be going into the project very soon, so keep an eye out on the social media channels that we have. Obviously the main ones being Instagram and YouTube. You'll see it going in, and hopefully this has been of some use and it has helped you understand the reason why we've been doing it in the rack as opposed to on site. From now on, I think this is the way we're going to be doing it. How you doing, everybody? It's Alex here from Art of Smart. I don't know where I'm looking at on the camera. Down here, not up there. Shall I start again, yeah? Right then.